Real numbers. First we go with the definitions. Number. So how we can define the number? A number is a word. A number is a word which specifies exact quantity. Which specifies exact quantity. For example, 2 balls, 3 cookies. So we are saying that 2, the number, exact quantity, 3 cookies. So what is the difference? See, a number is a word which specifies exact quantity. Specifies exact quantity. That means which is countable. So definite quantity, exact or definite quantity. Indefinite means you can see some sugar, but we cannot say exactly that is number of sugar particles. Some sugar, some water, little sugar, all few money. So that is indefinite, but this is definite. Exactly we can say these are 2. 2 means definitely 2. So exact quantity. So that is the definition of number. Next, natural number. Natural numbers. So generally we call them as counting numbers. Numbers starting from from 1 and up to infinity are called as natural numbers. It is denoted by, or they are denoted by, capital N. So the number starting from 1 and up to infinity. Infinity means you cannot count maximum number. So we are saying infinity. So we can say like this: 1, 2, 3, so on up to infinity. The numbers which are starting from 1 and ending up to infinity are called as natural numbers, and they are denoted by capital N. So you can say that N is set of the numbers starting from 1 to 3 to infinite. Whole numbers. Natural numbers. Natural numbers along with 0 are called as whole numbers. These are denoted by capital W. So natural number starting from 1, 2, 3 and so on. So along with 0, that means whole number start from 0, 1, 2, 3 up to infinity. So you can say that whole numbers is set of 0, 1, 2, 3, so on infinite. Integers. Whole numbers along with negative numbers are known as integers. These are denoted by I. Sorry, these are denoted by capital Z. That means whole numbers along with negative numbers means we are going to join negative numbers for whole numbers. That means you can write these integers as a set of minus infinity. So minus 3, minus 2, minus 1. These are negative numbers. The whole numbers are 0, 1, 2, 3, so on. If you observe this, from here they are whole numbers. So these are negative numbers. So negative numbers along with whole numbers are known as integers. Rational numbers. The numbers which can be written in the form of p by q, where p comma q are integers and q not equals to 0. Q not equal to 0 are known as rational numbers. These are denoted by q. That means numbers which can be written in the form of p by q, where p comma q are integers, q not equal to 0. Why q not equal to 0? See, if denominator is 0, it is not defined. So denominator must not be equal to 0 and p and q are integers. Then those numbers are generally called as rational numbers. These are the numbers between the integers 1 and 2. Of course 1 is also a rational number as well as integer. Generally the numbers between these numbers which are decimal numbers are called as rational numbers. See the difference between fraction and rational number. See, for example, 5 by 4 minus 4 by 9. See, it is a fraction. It is a fraction as well as rational number. This is only a rational number, it is not a fraction, because for fraction p by q, they are in the form of p by q, where p q are whole numbers and q not equal to 0. In fractions there will not be negative number. So whenever negative number includes, that is not fraction. That means all fractions are rational numbers, but all rational numbers are not fractions. So these are the examples. And moreover, rational numbers are of 3 types. So rational numbers are, can say, rational numbers can be written as 2 types of decimals: non-terminating recurring decimals and terminating decimals. Example: 1.5, 1.57. Here examples: 0.3 bar, 0.3 is recurring here, like this. So irrational numbers. The numbers which cannot be written in the form of p by q are known as irrational numbers. That means nothing but the numbers other than the rational numbers are irrational numbers, and we can say that see, rational numbers can be written as in decimal form. Irrationals are only in the decimal form. They are, you can say, they are non-recurring and non-terminating, because you cannot write in the p by q form. They are only decimal numbers which are non-recurring and non-terminating decimals. For example, 1.72364332, so on. See, we cannot estimate the next number. If you write the next number, you cannot estimate the other next one number. That means we don't know how series will go on. There is no clarity about the series. Then these numbers are, see, there is no not terminating. Decimal numbers are not terminating. Moreover, there is no pattern repeating, non-recurring. But in recurring decimals, you can write, see, 1.5 bar, that means 1.555, 1.676767, 1.67 bar, that means here 1.676767 is repeating. It is non-terminating, but there is a pattern repeating. You can say here 67, next one 67. So some sort of pattern is repeating here. You can say what number comes after 7. So these numbers are called as recurring and non-terminating decimals. So these numbers are called as recurring and non-terminating decimals. So we have such a pattern for this, but here there is no pattern, so that's why these numbers are called irrational numbers. Then we come to the concept real numbers. The combination of both rational and irrational numbers are called real numbers. They are denoted by capital R, and here these numbers are denoted by Q dash. So real numbers, the combination of rational numbers and irrational numbers, that means entire number system can be called as real numbers. So real numbers is a set of irrational numbers as well as rational numbers. When you consider the rational number, obviously we are going with integers. When you consider integers, obviously we are going with whole numbers and natural numbers. Apart from the real numbers, we have imaginary numbers, but we are going to discuss them in +1 or +1, not now. Okay. See the diagrammatic representation of real numbers, whole number system. So these are real numbers denoted by R, and this is Q, which are set of rational numbers, and remaining are Q dash irrational numbers. So this is a set of integers, because integers is a part of rational numbers. And from integers, in integers we have whole numbers and negative integers. Yes, whole numbers means positive integers and 0. Positive integers 0 and negative numbers comprises to become integers. That means integers comprises of negative integers and positive integers as well as 0. But positive integers 0 are called whole numbers. So in and only we have positive integers. So positive integers but 0 sum up to whole numbers. That means if we can say that all natural numbers are whole numbers, but not all whole numbers are natural numbers. Similar, we can say that all integers are rational numbers, but all rational numbers are not integers. All rational numbers are real numbers, but all real numbers are not rational numbers, because we have irrationals also. So this is the end of the session. So here go start with divisibility. So all of you know the divisibility since earlier classes. So definition is that generally we define this a non-zero integer a is said to divide an integer b if there exists an integer c such that b equals to ac. So when a divides an integer b, and the result will be the c. That means you can write this as b divided by a equal to c. So this is the general divisibility. That means here a divides b. Generally we can write this as a in the symbol a divide b. That means here a is exactly dividing the b, and this is the quotient. There is no remainder. That means remainder is 0 because it divides exactly. Then itself we can write a divides b. If a is not going to divide exactly the b, cannot write like this. So the symbol only when a divides b exactly, but this is different. B by a is different. Sometimes a cannot be divided b, but we can write that in the fraction form, but this is different. Whenever a divides b exactly, we can write this symbol a divides b, and this indicates a not divides b, or b is not divisible by a. Now we can go with the